All right, hey there. Welcome to Restrictions on Radicals. So what we're going to do is look at just radicals and see what kind of restrictions there are on x. So let's start with a square root of x. Well, I don't know if you remember trying this one earlier, something like the square root of -9, but remember it didn't work, and we had this little symbol that said it's not possible. Well, so that tells us right away the restrictions on x here would be x has to be a positive number. So how do we write that mathematically? We write x has to be greater than or equal to 0. Basically, it's just saying no negatives allowed. No negatives. Okay, that's the restriction. So that's kind of what we're looking at here. What if we threw some little mixtures of stuff at you? Maybe we looked at a cube root this time. Okay. Is it possible to take the cube root of a positive number, say positive 8? Yes, it is. No problem there. That would just be 2. And what about a negative number, like -8? Yes, that's no problem either. So are there any restrictions when you look at a cube root? No, it all works. It's all good stuff. So there actually are no restrictions on that. Just to show you the difference, what if I kept going and I said, what about a fourth root, say, of x? Well, this is a very similar thing to a square root. Because there's an even numbered bunch of groups here that are multiplied together, there's no way this is going to work if x is some kind of negative number. For example, let's say we said, I don't know, let's keep the number very simple, -16. Well, you've got 4 groups here, so this is always going to yield a positive product. You're always going to go a number times a number, that's always positive, times a number, which is always going to be positive. So the restriction on this guy would be, again, x has to be a positive number, okay? Because this simply down here, you look at that and you go, hey, I can't do that. And so that's our restriction on that. So let me just give you a summary of what kind of is happening here. If you are looking at the nth root of x, okay? Basically, if n is an even number, okay, so if n is even, then there's always going to be the restriction that x has to be positive, okay, or whatever is under the radical here has to be positive. However, if n is an odd number, whether it's a cube root or a fifth root or whatever it is, then anything basically goes. Then I guess I'll say anything goes for x. All right. So any number would be acceptable. All right. Sometimes though, and this is my tip before we finish. So you got to sometimes do a little bit of thinking before you rush in. You know, sometimes you can't just go, oh, that's an even number, therefore. You got to do a little bit of an analysis. Let me show you what I'm talking about. Somebody throws this at you. Okay. Notice this isn't just the square root of x, it's the square root of -x. So what you got to be thinking is, well, what's the scoop on the stuff under the radical? In other words, I'm square rooting stuff here. This stuff better be positive, or else this whole thing isn't going to work. So in other words, I need -x here to be positive. That has to be greater than or equal to 0. Now, if I solve this inequality for x, that means I'm going to get rid of this negative. So maybe I'm just going to divide both sides by -1. So it'll turn this positive, and this will still stay as 0. But whenever you multiply or divide by a negative and you're dealing with inequalities, you got to remember to flip them. Okay, so now, what is that telling me? It's telling me, oh, x is supposed to be negative. It's supposed to be less than or equal to 0. Does that even make sense? Well, why don't we try a number? Why don't we try something, say, like -4? Let's stuff that in for x and see why this is supposed to work. So I would go the square root of negative, and then I got to put in my x number, right? And I'm thinking -4. Well, what's going on is you're getting a negative, which turns this into a +4, which you're allowed to square root. So guess what? It works perfectly. So this is our restriction over here. And we kind of checked it out here to see if it really does work, and it works rather nicely. So let's try something else, a little bit more complicated, one that requires some analysis here. So this time I'm looking at the 4th root of, and I'm going to throw in there x to the 6th. And all I'm looking at here is I want to know about any kind of restrictions. Okay, are there any restrictions, and if so, what? Okay, because this is a 4th root, first thing I'm thinking to myself is, that means whatever I get inside the radical better be positive. Okay, in order for a 4th root to work, this got to be positive. So I want x to the 6th to always be greater than or equal to 0. And then when I start thinking about this, hey, whatever number x is, if I'm raising it to the 6th, isn't this thing always positive? Yeah, I think it is. So this is always positive. It doesn't matter whether x is a negative number. When I raise it to the 6th, it's going to turn into a positive number. So whatever number x is going to be good. So this is another one of those any x will work. Any x is good. So what's a more nice way of expressing that? Saying any x. Well, usually it's done this way. Okay, x can be any number, and usually they write it with this funny little symbol, and they write it like that. Now what they're really saying here is x is an element of the set of real numbers. So what this funny symbol means is x is or can be any real number. Okay, and real numbers meaning all the whole numbers, all the integers, all fractions, positives, negatives, zeros, even funny numbers like the square root of 2, irrational numbers. Any of those are going to be fine because when we plug them into this, they're always going to be positive. So we're pretty happy about that. And that's where I'm going to stop today.